Hello everyone, this is Naidu from Techno Legal Forum. Today we'll discuss about various crucial topics under cybersecurity. Today class, today's class is a different one because today I'm going to cover topics very briefly because I want to cover all the topics so that you will get an idea of what's going to come in upcoming sessions. Today I'm going to cover all these topics very briefly because in upcoming classes I will take one topic per session. So there are various topics starting with encryptions, hashing algorithm, challenge authentication protocol, and SAML, Kerberos, various protocols, the exact communication paths. So all this I have prepared the slides. So this cannot be done in one session. Therefore, today I will cover all these topics are connected, how they are interrelated. So that helps in upcoming classes to grasp every detail. Okay, so let me move to the first. Let's start with number one, that is identity access management. So this is the most important pillar in cybersecurity. Okay, this is the most important pillar that needs to be if this is implemented very effectively in an enterprise or in an organization, then most of the attacks can be minimized. So this is the most critical and important pillar of security. Identity access management. The understanding of these terms also very important. The first one is identity, IAAA framework, identity, authentication, authorization, accounting. Then followed by CIA, confidentiality, integrity and availability, security triad. These are implemented using this technology. To roughly put it in a very quick session, so let's take I. What is I? Identity. So what is identity? So I have a name, Naidu. I am saying Naidu. Am I really Naidu? I am claiming myself as Naidu. How do I, in a general analogy, prove that? Aadhaar card, passport, right? Similarly, in the networking world, in the organization where the entities are there, like systems, users, processors, how do they identify? So very roughly, if I have to say, this is a user laptop, this is the internet, and this is, let's say, this is the server. So user one is an identity of this person. How do we prove it? He provides username and password which travels across internet. If it is organization, within the organization, this server has a database, or we can say active directory, where these credentials, the user one and his password, are also here. So when he supplies username and password, they are validated. Is nothing but identity is established, or identity is authenticated. If this username, if it is not, rejected. So So this is the first IA of AAA. Once you are authenticated to the organization network, why you are authenticating in the first place is because you want to access the resources, right? That's the whole purpose, right? Whether inside it is connected through Wi-Fi or through VPN, once he connects to the organization, you have a lot of resources. It can be file server, application server, printers, everything and all. First step is done. Identity, that is nothing but identity, and first step, that is identity is established through authentication by providing username and password. So there's so many ways, like see, we are just using as a password, so it can be what you know. These terms are very important that we cover. What you know, what you are is like biometrics, okay, and what you have. What you know is like password, code, something. What you have means something physical you have, swiping card or hardware device generating some code, OTP code. I'm talking about the OTP which comes within the from the device which you generate yourself, or it can be a mobile device where you can generate the auth code, right? So that is nothing but what you have. What you know means it's there, you alone know. It's a kind of secret password, secrecy that you have. Other two is what you are. What you are means as a person you have some biometric features, fingerprint, retina, iris. So those things can also be used for authenticating yourself. Then the other one is where you are. Like where you are means geolocation. If you are allowed to log in, when you only log in from a particular location, particular system, particular IP address, particular network segment. This is the fourth way of getting access. So I don't want to go in detail. We will catch that in the when we are discussing detail. So that is the about authentication. So those what you are, what all these things what I told implemented. That will the implementation part is taken care, and that establishes our that's authorization. Once you get inside the network, you are going to access the resources. Accessing resources, what is that you are going to do with that resource? Suppose if it is a folder, you might have read only, read write, delete, right? All this is nothing but authorizations or permissions. How these are implemented? These are implemented using access control. These details again we will discuss in depth when we go. Access control list or assigning a user to specific roles or policies. Using policies also we can implement authorization. So third, second day, first day, second day. The third day is accounting. Accounting is nothing but when the user logs in, from the time he authenticated until he logs out, various activities done by the user or by the systems or anything, that logs get generated. Logs are getting captured. Why logs are getting captured? Because it might be required for auditing purpose, for troubleshooting issue, all these things. So accountability. So in accountability we have some concept called non-repeat. See, if you have logs or accounting, non-reputation is some term we use. Reputation means, it's a very important term. Reputation means action which I perform, I can deny it that I have not done. If there is no log, right? You can do that. Non-reputation means what are the actions you have done, you cannot deny it because we have a logs. So establishment of non-reputation, non-reputation term is important and is also useful for legal purposes, right? You can track on forensics and other things. So we have now just very briefly, there are a lot of things supposed to be covered, but we have covered very briefly IAAA. Okay, let's go back to the main. So these topics, this is the most important, hashing and these are the foundations of all the protocols that we are going to study subsequently. If we have a grasp of these two, hashing under encryption, symmetric encryption and asymmetric encryption, if you have a complete grasp of these things, understanding this working of these protocols makes much easier. Hashing, encryption, there is something else, digital certificate. Okay, so these are the whole underlining technology that will enable this, what we are going to discuss about the protocol. So let's go back. So before we go to discuss about encryption, there is a very simple protocol which might not require those, the first two protocols may not require the understanding of the encryption and hashing. Okay, so PPP is a point-to-point protocol. This is more about establishing a link, a channel between the two entities, two devices. It is something like a highway, national highway. Okay, and protocols, what we are going to discuss are the one which work on this link. So authentication, point-to-point protocol is establishing a link, and on top of that link, these protocols will be used. Okay. So in password authentication protocol, PAP, that's a very primitive protocol. Earlier, now it is no longer used, wherein the username and password is sent over the untrusted network, we also call the internet, to the server where this client supposed to get authenticated. And the server, when we say server, like Active Directory, it will check these details and provide access. But the biggest disadvantage is this username and password are sent in a clear text over a untrusted network. So there is a complete breach of security. It means like eavesdroppers or hackers using simple tools like Wireshark or TCP dump can in fact take these details and act as if they are the one who are communicating. See, they can take this username and password. There's a hacker. It takes, using the Wireshark tool and other packet capturing tools, it takes these details and he starts communicating with the server. The server thinks that this is a man in the middle attack. We call it the man in the middle attack. This server thinks he is communicating with the client, but in fact he is communicating with the hacker. So this is the earliest protocol, I would say. It's a very important topic that we are going to discuss. Encryption is also, we can relate to in CIA triad, also represented by a triangle CIA. Every organization strive to have a excellent CIA. So when it comes to the data, confidentiality of the data, how the organization ensure the confidentiality of data. Confidentiality means data that not supposed to be seen by everyone should be confidential. What technologies we use is nothing but encryption. How strong the confidentiality of the data, how strong the integrity of the data manipulation, the data which is sent from one source to another, or source to destination, should reach as is. There should not be any modification of it. How good organization establishes that is integrity. Okay, that is done through hashing. C is done through encryption, I is done by hashing. So hashing is implemented through latest SHA-2 or 256-bit algorithm hashes for data. And here we use symmetric and asymmetric encryptions. Okay, so these two are important. A means availability. When you need the data should be available. It is like ensuring you have high availability options, availability technologies for both for the applications and also the hardware, right? So within milliseconds, our load balancing and other things we can, and shadow, what you call redundant. Suppose within the organization you have two data center. One is acting as a replica of the other one, right? When there is a mission critical data or financial data, HR data, application should be online 24/7. If there is something goes in one data center, immediately the application will connect to the other data center database within milliseconds. So the end user will not find the difference. So that is the implementation. That is nothing but availability. Why should that CI? Why we should have that? Every organization should try to have the biggest very excellent CI implementation, because CI organization, if it has very excellent CI, its credibility increases. Credibility will increase the reputation, because a customer is more worried about security of his data, right? The customers who are signing the contracts with our organization, his concern is about confidentiality, integrity, availability. If the organization is providing excellent CIA, it's in the eyes of the world, its credibility increases along with its reputation. When reputation increases, trust increases. When trust increases, organization, more customers will have a tie-up or sign contracts for their projects. So these are all is connected to CI, and CI is implemented through the technologies what I mentioned. Now, one point before we end on the CI, who will certify that CI a given organization has excellent CI and other organizations uh, below par through auditing, IS auditing, information system auditing. So there are standards like SOC 2. So is a third party which does the auditing, and it will check every technological aspect of organization, even organization controls, and all the aspects of how it's managed. So excellent SOC report will obviously will be most of the organization has to be compliant with one or the other, but the findings from the auditor post auditing, those values and everything will ultimately increase the credibility of the organization in the IT world. Okay, now coming back to the encryption. Encryption is nothing but taking a readable data, we call it as plain text. It can be a password, it can be a document, so it can be anything which goes into this block, which is nothing but algorithm, mathematical cryptography, that is nothing but algorithms and a secret key. Using this algorithm and secret key, this plain text or any input which we are giving here, it becomes a cipher text. Cipher text is a technical word. It's nothing but the hello bar here, it becomes a junk kind of string characters. So this becomes like this. Why this is needed? This we are talking about is untrusted network here. My writing is so bad. Okay. This is a untrusted network. So we are always vulnerable from hackers, eavesdroppers, state actors. State actors are those who have the organization meant to do the hacking on enemy or enemy countries. This so much dark web and all. So all these are there here in the here. So the purpose of encrypting means make it kind of unreadable. So if man in the middle, at least even if he captures the data, it's no use for him. It's nothing for him. He can't use that data to act as a this person while sending. So that is the purpose of encryption. Within the organization also, we have certain data need to not to be seen by everyone. So levels of what you call sensitivity. Even those cases, encryptions are used. In many ways, it is used. Multiple applications with that we come in the lead. Even HTTPS, how a server communicates. When the user sends username and password over the browser when he's connecting, the entire thing gets encrypted, and get decrypted at the server. So here, this encrypted stuff gets decrypted using a similar algorithm and a key. One very important aspect is this key and this key are same. In other words, this key nobody else knows in the world except the sender. Very, very important. And the receiver. They shared the key ahead of this communication of data. They would have shared the key in a very different way, not over the internet, because again internet is this thing. So they would have used that's why it is called, since a single key is used for encrypting the data and the same key is used for decrypting the data to get back the message sent by the sender. Since the same key is used, it is called symmetric key. One disadvantage is means key distribution. The biggest disadvantage of symmetric encryption, how do you distribute the key? In what means? Right? This is a big challenge. But the biggest plus point is of using encryption, symmetric encryption is excellent speed. The algorithms and the key length, everything that uses it uses less processor speed for encrypting. For example, entire hard disk has to be encrypted. We have to use the symmetric encryption. It is very fast, much faster, much faster than in relation to the asymmetric encryption. But biggest advantage of asymmetric encryption is it is highly secure. There is no problem of key distribution. We'll come to that. Okay. This is very important because the digital certificate and the protocols understanding becomes much easier if we understand asymmetric key encryption is also called public key encryption. Okay. Sender is sending the plain text to this algorithm. He encrypts. Remember words important here. Sender and receiver. See, it's always like key pair. Public key, private key. In asymmetric encryption, we always talk in terms of key pair. Public key because it is not confidential. Everyone knows this public key. Private key is confidential. Only a person who has it. For example, sender. Sender has this pair. Look, I'll just add S. S sender's public key, S sender's private key. Here receiver. He also has two pairs. I'll name it by R public key, receiver public key, receiver private key. Because this very important. This is where always confusion happens. Now sender. Let's say sender is sending. First, it need not be only sender. Even receiver will be sending the messages. But now for the understanding, sender is sending plain text, encrypted plain text. It becomes a cipher. Remember, sender is sending. Let's say sender is sending. If he is sending a encrypted text, to whom he is sending? To a receiver. What he should do? He should use receiver public key. Remember, public key of this person, public is known to this person, public key of this person known to this person, all the world also. Very important here. Public key of sender and public key of receiver, both of them know each other. Since he is sending to this, because only one pair, we are talking about two people here, receiver, recipient here. Since he is sending a plain encrypted text, in order for him to decrypt, he has to encrypt, because see, public key is used for one important step I forgot. Public key is always used for encryption. It may change later, but for this discussion, public key is used for encryption, Private key is used for decryption. Same thing. If the sender is sending a message, encrypted message, what he should do in order for this recipient to read it? He should, very important, he should encrypt, because he is sending the encrypted, right? What key he should use? That this recipient's public key. Recipient's public key. He uses the recipient public key to encrypt the text. It becomes a cipher text. When it reaches the recipient has a corresponding private key, because these are linked. Public key and private key are linked to this person. Similarly, this. Since this person has to read, he has to decrypt. He has to use the private key. See, private key only this person will have. Only this person. His private key will not be known by this person. This person private key will not be known by this person. Therefore, if you are sending some text message encryption, you want to do encryption and send it to this person, you have to use his public key. Suppose if he uses his public key, the corresponding private key is here. This key he doesn't have it, he only have. How he is going to decrypt it? Therefore, the sender will always should keep in mind to use the receiver public key and encrypt the message. Once he encrypts and it goes, he already knew that the private key is already, this guy is, its public key, receiver's public key will also, while this guy generated, he will have his private key and it is secret, nobody knows on the earth. So you will use this private key to decrypt it. Okay, let's take the reverse to get the grasp of this. Now this guy has to communicate back with some message. He takes a message, right? What he should do? He should use the public key of the sender and encrypt it. Okay. Once he encrypts it, it reaches here. In order to decrypt, the corresponding key is private key. So he uses the private key. So this is how this works. Since this public key is, we don't have to hide it. Private key anyway with these people. So the biggest problem of previous encryption, that is key distribution, is totally resolved. You don't have to worry about how do I share that single key with that person, whether the way I shared, is it secure, somebody has hacked it, all these problems here. But another biggest disadvantage of asymmetric encryption is, since a lot of algorithms and multiple keys are used, key pairs are used, the mathematical calculations and process intensive operations, it is much slower. Maybe it is like 1000 times slower than the symmetric encryption. Therefore when you are communicating over the when you want to encrypt large sums of data, asymmetric is not a practical solution. So what they do, if they want to do large sums of data encryption, first, in order to establish secret channel between sender and receiver, they will use the asymmetric encryption. Once that is established, then they will use the symmetric encryption for transfer of encrypting large amounts of data and transferring to the destination. So it is nothing but hybrid encryption. We call it as a hybrid. This is our, this is also the secret behind browser connecting to internet, sending data, encryption happens, right, using hybrid encryption for establishing secure connection. Asymmetric keys are used to establish a connection. Once the connection is established, it becomes like a secure channel kind of stuff, conceptually. Then it switches to symmetric encryption. Therefore, it's able to send and receive large sums of data. Okay, we'll cover this hashing and we will pause, and the next session we will take up the very important protocols that we discussed. Symmetric encryption, single key; asymmetric, public key pairs, but corresponding keys has to be used for encrypting and decrypting. That is also foundation for our digital certificates that we'll discuss later. Now coming back to the hashing algorithm, it establishes I of the CISSP triad. Integrity of the data what is sent from the source to destination should arrive at the what is sent at the source should arrive exactly at the destination without any manipulations. That can be achieved using hashing algorithm. So very important and very interesting topic. What we has algorithm. Secure hashing algorithm, 256 bits. This is the name of the algorithm. The older version was message digest, right? That was not secure enough over a period of time, because the multiple combinations which it is to the key will actually provide combinations, the number of combinations that was quite big at those times, but over the technology and the computer speeds have increased to a large extent. Those would have been earlier it was not breakable by 100 years. As the speeds are increased, processor speeds are increased because of the improvements in the hardware. Those instead of 100 days, it was able to break in a day, right? So that's why they are not secure enough. They are breakable, so that's why they are not no longer used. SHA-256 is what is been currently used, and even due to advent of quantum computers, right? They're very faster than the traditional hardwares what we have. Even this may get weakened in a few years from now. Hopefully by that time there will be other methods or features that could be implemented to ensure that it will stay longer, or new ways of protecting the data manipulation or the integrity, ensuring the integrity will also be available in the world. Okay. Now coming back to the how it works. This is very important here, what I am highlighting here. Input any length means it can be a document of 500 pages or a movie file of in gigabyte size, or it is a password of some 10-15 characters. Input is infinite. Always remember, input is infinite, and the output, very important here. Fixed length. One statement, input is infinite. It can be 2 characters, it can be in GB. Okay. Output is always fixed length. It means even if I give 2 characters in the input, if I give 2 characters or 1 GB file or 10 GB, any size, output is always 256 bits, or it is also 64 hexadecimal characters. See, 256 bits can be converted or represented in 64 hexadecimal. That is what you see the representation here. It's actually 64 characters here. EF. Okay, hexadecimal means 0 to 9, then continue with A to F. F is 15, A is 10, B is 11, like C, D, E, F, right? This much. So you can convert a binary zeros and 1. We are talking about 256. Zeros into 1 into hexadecimal for easy representation. So any length, any 2 characters, whatever, even if you give 1, it will always be giving 256 or 64 character. 64 character hexadecimal. Remember 64 because it's 256. Algorithm takes the input of any size, always produces 256 characters. Okay, here the example, let's see, password 123. This is also password 123. The difference is case. First I said about the length. Next is here a small case variation. You can see here the 64 hexa characters. This is for password 123. This matches to this. You can see a different unique hexa. It starts with 482C, EF29. Right? This one starts with 48. This is for a password which is having a capital P. So enter this. So it means that even if even small change, 1 dot, punctuation, anything in the input will alter the 64 hexa characters. It becomes a unique. Okay. This specific feature is what the application of hashing algorithm. Right. Let me quickly give an example. Let's say this is a 500 pages contract, confidential contract, CC, that I need to send over a untrusted network to a receiver. I am the sender. I have to send this one over the untrusted network. The contract means it should not be manipulated. See, we are not talking about confidentiality. We were only talking about a document which is coming from point A to point B, point A to point B should arrive as is exactly. Okay. In order to ensure that it arrives equally, you feed this document into hashing algorithm. SHA secure algorithm 256 bit algorithm. Remember, any size, less size, more size, regardless of the length, it always generates 64 hexadecimal characters or string of characters, 64, right? We call this as the 64 character, we call this as hash of the document. Now take this hash, take the document, send the document mentioned as 1 along with hash. Okay, take the document, feed it to the algorithm. It generates a unique 64 hexadecimal character, that we call it as a hash 64 character one string. Now send the document along with the hash to the receiver. What happens here? The receiver receives both the document and hash, correct? Now how can he make sure the document which was sent by the sender is the one he is receiving? Because he knows that it is traveled through the network with so many hundreds of intermediate devices, hackers, and everyone might be there. They would have they would have manipulated. Let's assume they would have manipulated. How do you ensure that this document which has received is as is? So what he does, very simple. It takes the document first. First it takes both he downloads. First he takes the document into consideration. Then he will use the same hashing algorithm, 256 hashing, and generate hash. Let's say H2. Please remember, if there is a single bit change in the document, the hash will also get changed. That is where the secret here. Now is generated H2, right? Of the document, right? Then this H2 and the H1 that he received over from the sender, he compares them characters by character. If the characters are matching exactly, then the document is not manipulated. Simple. Remember, hashing technology is one. If there is any slight manipulation, then it produces a unique hash. So since there is no manipulation, you can be best assured that the document what was sent was received. If there is a change, then obviously in between it could be technical reasons, it could be human reasons, or whatever, it got manipulated. So that is the biggest gift of hashing technology, which also prevents piracy of the piracy is one of the biggest challenges in the world, right? Somebody uploads a movie, the original movie producer should only be sold. If somebody copies that movie or modifies that, copies and alters some things and says it's my movie, the movie which the producer uploads, he'll also corresponding 64 hash he generates for it, unique hash, which exactly represent the original movie. So when the people download, assuming if they are downloading, they'll download and generate the hashing, it should match. Then is the hash should be matching this one. If the hash is not matching, then what they downloaded is not the genuine movie. So that is one of the biggest advantages. There's so many other applications of hashing technology. One is the biggest is your digital certificate, that we will discuss in the next class. Okay, so this is all about critical parts of the slide, that is the IAAA, CI tried, and hashing and encryptions, types of encryption and its applications. Next class we'll talk about the password authentication protocols, then various other latest protocols currently in use. Okay, thanks a lot for joining this session. We'll catch up in the next session. Have a good rest of the day. Bye.